to all of us today. And hopefully in the next 45 minutes, I will be able to show you and to demonstrate the applications of AI, but not just AI, specifically generative AI in sort of transforming and also optimizing exploration processes in energy exploration, and also mostly in oil and gas exploration to become more sustainable. Let's start. But before we start, I would like to first acknowledge all the contributors, all my students in the Predict Research Group that I have here, and also all the collaborators that have really put an effort and time to contribute to the some of the results and findings that I will share with you on our current research using generative AI to optimize mostly geoscience interpretation. I mean, I already introduced myself, but I would like to just reintroduce myself again. My name is Ardi. I'm an assistant professor now at the University of King Fahd University of Petroleum and Minerals. And I mean, all my geological journey really started back home in Indonesia, and then from there on, I moved to several places across the globe, and I had the chance to visit different areas, different places for research or just collaborations that really allow me to to be able to appreciate the complexities of geology, and also to understand what's exactly going on in our Earth, right? And along the way, along my journey, I've met many amazing people that really shaped me. I am now. So again, I think this is what sort of the perks of being geologist. You are paid to travel, so and you're able to see the world, right? Doing what you like. So before I joined the university, now I was a postdoctoral fellow at Stanford University, and this is really where I started my journey in terms of using AI for geosciences, right? And try to apply it on how we can use it to optimize hydrocarbon exploration. So if you look into the the pathways also, or the future of the energy mix, as we are all aware that with the recent technological advancements, and also with the big push towards more green or renewable energies, we are expecting to see more and more contributions of these different renewable energies, such as geothermals, hydrogen, so on and so forth. But then there is something that we cannot forget is oil and gas is still pretty much the backbone of all this the energy mix that we have. Even with all these new renewable energies, I think it is very difficult for us to really move away from oil and gas. So then our our homework is how can we make this exploration of oil and gas production and exploration much more responsible and sustainable, and one of them is through by using AI there. Just a quick summary on how AI really impacting our industry. I'm sure you have heard about this, and you have seen really the booming of applying AI or adopting AI and big data science in different aspects of oil and gas. But one thing I would like to emphasize is really the main value when we talk about AI for energy exploration is mostly in predictive analysis, and this is what exactly that my group and my research group here are currently doing. We try to develop a predictive analytics that will help exploration and development, right? And as you can see here, also mostly AI really impact the exploration and discovery, right? So our focus today will be how we can use AI for this sort of exploration. And then if we narrow it down and we zoom in into generative AI, I think in the last few years, this is what been sort of part of our day-to-day life, right? I mean, you know, like Chat GPT and all this. But generative AI is not only Chat GPT; it's beyond that, and it's even sort of discovered way before all this Chat GPT happened, right? And the impact is sort of very direct and also very rapid. When you start applying this, I think there are different aspects from data analysis interpretation all the way to decision support will be really benefiting from this technology, right? And the whole sort of like the bottom line is how can we use this generative AI to make exploration much more efficient and also accurate, like remains accurate. I think that's something that we need to keep in mind. We don't want to just use AI to optimize or to make our works much faster and easier, but also we want to make sure we maintain the accuracy, or how close is the interpretation with our own human or expert interpretation. So a little bit stepping back, if we look into the history of generative AI, as I mentioned, is not something new. I mean, if you really talking about generative AI, things it's all again dated back in early 1980s, even 60s and 70s. But I mean, during that time, I mean, we don't have the capacity, we don't have the resources that we have today. So then I think, started in 2010, this is where we really can, leverage this technology. And then from there on, you see the growth of this technology and how this technology is advancing very rapidly. And especially, there are a couple of sort of seminal works. For example, this by Ian Goodfellow back in 2014, where he introduced, or they introduced, the generative adversarial nets. And as you can see, like this paper alone has been cited more than 70,000 times, right? So you see how impactful and how people really adopting this technology now. And when we talk about GPT and all this, I guess we cannot, forget about this paper, which is all started with this paper. Attention is all you need, and this is where they really revolutionize in terms of large language modeling, and they built all this GPT and all the subsequent development. And this paper, as you can see, has been cited 130,000 times, right? I mean, this paper was like published 2019 or so, or 2018. And just within these few years, they get cited, really a lot of times. So I will say these are the two really seminal papers that sort of transform the landscape of AI in general. And now it is our duties to really know, or to really explore how we can adopt this technology in our field, right? So just a bit of a background when we talk about generative modeling, generative AI. If we try to use a simple analog, I think one philosophy that is really good capturing this is by Richard Feynman, where he said basically, what I cannot create, I do not understand, right? And with generative modeling, as by the name itself, is the ability to model and generate something, right? And the backbone of this is what I understand I can create, right? So this sort of help us. I mean, as you know, when we talk about AI, machine learning, some people are really skeptical. They say that it is a black box, this and that, right? You can make a very high accurate predictions, but we don't know how the algorithm actually did it. But with generative modeling, the model itself needs to really understand what is your input data, or what is the parameters that you are using. Then from there, it will be able to generate something, or to be able to create a data from it, or create something new based on your data. So if we look into generative AI, it's mostly adopted in image generation. Like back in early 2014, they were able to generate something, but as you can see, the quality is still very low resolution. But you still also, sort of deform object. It's not really representing the actual real world object. But then back in 2021, then you can create something that even our human eyes will not be able to differentiate which one is AI generated, which one is real image, right? And then nowadays, you have much more flexibility where you can even just using a simple text and as as random or as wild as you like, and then the algorithm will be able to generate an image from it. And this is something that we don't have in the past, right? I know, like, again, some people that talk that the AI is not something new, this and that, but then when we talk about generative AI, the ability that we see generative AI can do today is not something that they have seen in the past. So this is quite a, again, quite a, a big change, and also really, sort of transform how we can use AI now and also in the future. So then if you talk about generative AI and exploration, what we can use it for, and should we be excited? Like, we know that all this, everything surrounding us is using generative AI now, but in terms of exploration, how can we really get the benefit of it? So it seems this is, again, this is something that people in industry are really thought about it very carefully, and they really wanted to adopt it. For example, like Aramco built this recently, Meta Brain, which is probably like the first the largest industrial large language model, or like the largest industrial sort of chat GPT or chatbot. And this is all, again, based on generative AI, right? So there is a real interest here in terms of using generative AI, and they can really see the value, or the added value that this technology can provide in our industry. In terms of in geoscience, or in more or less in our field, again, there are a lot of papers now coming, a lot of discussion related to this. Again, this is all one of the key papers that have started focusing on using this big large language model, generative AI, for focusing really on geoscience. So I think this is all a good sign for us. This is probably the time for us, especially if some of you in the audience are student or like early career. I think this is also the right time for you to get to know about this technology better, and see if you can really get use it and get the benefit from it. But unfortunately, sometimes not so fast, right? Most of the time, we are our own worst enemy. Like, if you look at this paper, I mean, this is very well known. Again, some of you probably have seen it before. This published in really high impact journal. But you see, in introduction, like the first word they mention, or the first sentence they mention here, is exactly what ChatGPT will write, right? And this is published. This is passed through the editorial, the reviewer process. So again, we as the user, it seems that we don't really use it properly, and we don't really take a good look when this technology has been used. And one of a really well-known problem also related to this, when one of the papers that get quite cited a lot, they created this and this image, and not long after that, there is a tweet that saying completely this is AI generated and it's totally incomprehensible. But again, this is passing the reviewer, passing the editorial process. It means, I mean, one thing, if you think about it in a sort of a positive note, is how good is this technology now? Like, even the experts, human, now we cannot really capture this. We cannot really as easily differentiate which one is generated by human, or which one is by AI, which one doesn't make sense, which one makes sense, right? But in the same time, if we don't use it responsibly, I think this can sort of backfire. It can create more issues than solving our problems. One of the biggest concern when we talk about generative AI is what they call these hallucinations, right? And if you have use ChatGPT, if you have tried it, it can, spell out all the information, sometimes even bringing fake informations, right? Or sometimes even fake citations, fake papers, so on and so forth, which is completely, irrelevant and also completely not available in reality. So how do we capture this? I think again, this is still a big issue for us. If we don't pay good attention, then um, it can still happen, and most likely it will happen, right? Because at the end of the day, when the model try to generate something, it needs to have this aspect of hallucinations, right? So I guess it's our job now as the domain expert to be able to, to capture this and also use it and responsibly. Why do generative AI can hallucinate? Mostly related to limited training data, some biases in training data, and also noises, right? And this is something that in our field, in geoscience, petroleum engineers, and oil and gas exploration, mostly we are sort of hindered by this condition where we have limited training data, right? Because when we talk about the development of all these technologies, they are using millions of data set. That's why we call it big data. But in our field, mostly we are dealing with, hundreds, thousands, if not only tens of thousands. So there is a huge possibility, if we don't use this carefully, then our tools or our algorithm will create these hallucinations, right? So just keep this in mind. I guess this is something that we can handle, but this is something very, very important to note. Okay, so now why do we need generative AI in geosciences? Mostly is, as I mentioned, our key challenges is the data set is very limited, and if we want to obtain a new data set, it is very costly. And not only that, if you think about training an algorithm, we need a label. That means you need to tell the algorithm what they are looking at, right, or what they're looking for. So labeling a geoscience dataset or petroleum dataset is not easy because you need an expert. You cannot just ask, random people or anyone to label your dataset. So this become, again, not only laborious, but also very costly to do. So if you look into the typical hype cycle, technological hype cycle, we always have this trigger when we have innovation. Then we have this peak of inflated expectation, and then we have this trough of disillusionment, right? And then after that, we start to understand what the technology can provide for us. So then the biggest question is, where are we now? Okay. Are we still in the peak of inflated expectation, or we already passed it through and we are here? We are, sort of, moving towards the slope of enlightenment. For me, I'm quite, positive and very optimistic. So I think we already passed this peak of inflated expectation. We are probably somewhere here now. So it's just a matter of where we are in the future, right? So there could be three different scenarios. Like the first one, if we keep doing what we are doing now, it means that if we just use this technology, try to apply it to get the result, and then move on, I think we'll reach to a plateau very soon where we will realize that this technology has huge limitation. But then if we can develop a benchmark open data set with minimum labeling, this is where exactly the potential will be able to be much more useful for us. And finally, if we can have all this and it's become more transparent and explainable, the model and human or the experts can put more trust in the model and in the results. I think this is where we can really achieve the actual potential of the technology. And so when we talk about generative AI, it's mostly in the second point, where the ability to generate new data, which is mostly synthetic data that really represent the real data, which is realistic. This will help us to create a much larger data set and ability to make it open for benchmarking. And then I will show you also later on by using this, because the model now is understand what they are doing or what they are seeing. then most of the time you don't need to have a lot of labels to train the models. Okay. So if you look into geoscience, mostly if you think about image analysis, we are dealing with multi-scales, multi-attributes data set going from remote sensing, Earth observations, all the way down to micro scale, thin sections, and also we have seismic in sort of larger basin scale. And our job is to be able to integrate this, doing the analysis, and come up with some hypothesis, or come up with some interpretation that will help the exploration. So we are in good shape, because we as a geoscientist here, mostly we are dealing with a lot of image data sets. So applying generative AI will be sort of exactly the right thing to do. So some of the past work that I've done before, not really using generative AI, but this is sort of the what sort of motivated me to use it. So in the past, we used this convolutional neural network, which is sort of the deep learning that is work really well with image analysis. What we can see here, we did a survey where we asked geologists with different backgrounds try to classify carbonate samples. And what you found is the accuracy between experienced people and deep learning is not too far. But one thing that's really amazing is when we think about the rate of classification. For example, in this case, in 1 second, the deep learning can analyze thousands of images with that kind of accuracy, right? Because if you ask human, once you ask human or geologist to analyze, hundreds of images, then again, human, we get tired. Once we get tired, we start making errors. So then that's typically where the mistakes and errors happen, right? When you try to analyze a huge amount of data set. So this is again something that we can use to optimize one of our problems here. And we sort of expand it, and we use this for sort of real-time petrography, where you can give directly different slides, put this technology in a camera, and then it will tell you what exactly in your slides, in your thin section. And as you can see, it's not so much on research, but it will really help mostly in, let's say, education, and also bridging the gap between geoscientists and engineers, petroleum engineers. Sometimes we talk about rocks, minerals, we get too excited, and they will be in the dark. They don't know exactly what we are doing, but with this, I think it will help to show them exactly what we mean when we talk about the specific rocks, for example. So this is back in 2020. Now we're in 2025. So again, this technology advances very rapidly. So it's all about now generative AI. So from here on, I will show you a couple of research that my group have been doing so far. Mostly try to divide it into 3 different aspects, which is generative modeling, foundation models, and large language model, GPT models, and how we use it to help us optimize different problems here. So quickly about generative modeling, we have 2 different sort of concepts, which is the adversarial networks, where you have 2 different models that sort of works against each other, which is like a forger and detective, if you like, where you have the real data set here, you give it into the detective to train them to be able to differentiate between real and fake, and you have the forger or the generator that keep generating until the discriminator will not be able to differentiate them anymore. Like once the discriminator cannot differentiate the fake image between fake and real, then this is where your model will be able to generate a realistic synthetic data set. And the latest one they have is they call it stable diffusion, where they introduce noises until it's all completely just noise, and then they try to reconstruct it back. And again, this process also help the model to generate new data. And this is basically what you have embedded in ChatGPT with DAL-E and all this, where they are able to generate images just from text prompt. So this is one of the first works that we did when talk about generative AI. So our problem again when we try to analyze thin section is the limitation, which limited high quality data set. Then our solution is try to use GAN or generative AI here to create a data set, synthetic, but also self-labeled, right? Because the idea is once you know how to create a sandstone, for example, or limestone, then you can just create thousands of this limestone and thin section or sandstone thin section as much as you like. So as you can see here, again, this work is already published. If any of you are interested, just let me know. But you see, this all are not real, right? All these thin sections are not real. They are all fully synthetic generated. But in the same time, as you can see, it looks very real. And even again, we run a survey, and it is actually quite difficult for a wide range of expertise to differentiate between real and not real, right? So again, this gives us a good sign that yes, we can create now a huge amount of data set that is very realistic. And then now the next thing is we try to repurpose this. As I mentioned, label is a big issue for us. For example, we try to do this pore segmentation from SEM or CT scan images. And in this case, we just try to use one label. It means I just try to label this image. Then from there, I propagate the results using sort of this generative AI concept. And then from here, you can see how the model can segment out the pore space from the grain and achieve pretty good or quite high accuracy. In this case, we really minimize the efforts in labeling all this data set and still achieving a good accuracy. Then we expand it all the way to completely different scale, from micro scale to seismic volume. As you know, sometimes when you run a seismic survey, there are a couple of areas that you cannot just run it because it's it's a settlement or some restricted area. So then you may have some missing patches, right, in your seismic volume. So in this case, we use generative AI to reconstruct. For example, here in this example, we masked the area here. This is the actual data. This is what we masked, and then this is the predicted data. It's not perfect again, but then it shows a pretty decent reconstruction. This is still an ongoing work. That's why I think we can still improve it, but we can see the potential there. And the last thing, one of the recent works of my students using this generative AI is to do property modeling. With reservoir modeling, as you know, we really depend on, especially static geomodeling, we really depend on geostatistics, right? And sometimes it can have a lot of uncertainties and biases. So one way we try to approach this issue is by using generative AI. We call it pix to pix, which is pixel to pixel, where you can have, let's say now you have lithofacies or facies model, and then from this facies model you get the porosity model. So you can go back and forth or in different porosity permeability. As you can see here, this is my lithofacies model, and I get the porosity. This is the predicted. This is the ground truth. You see it's pretty close. And the same with permeability, right? So in this way, again, it's not about replacing the geostatistic model, but it helps to optimize and minimize the time required to create different realizations related to this model. And then it will become much more efficient when we input this model into dynamic fluid flow simulation later on. Another thing is where we try again with a carbonate dataset. As you can see, this is all are synthetic. This is not real images. But also what we can do is we can now go from text to image, right? So I just want to, for example, I want to create the specific lithofacies, which is rutstone, and then I can get the image. The same here. And this is, again, you can go vice versa, right? For example, I have the image, then I can get the text description of it. So if you think about this technology, I think this can also help, let's say, for example, in core description or thin section description, where you can just bring the image and get the corresponding description directly from there. So now related to foundation models, I'm going to talk about foundation models. This is again, it's very different than what we have seen before in terms of machine learning, where typically you can have an input, specific input, and then you train it and you get the output. And then for different input, or data types, you need to have different models, right? But for foundation model, this is sort of, a large, massive model that can work with a huge amount of information without any label, uncurated. And then it can be adapted or can be fine-tuned to many different downstream tasks, right? So you just need to train it once with a huge corpus of data set with no label. And then once the model are able to learn from this data, then you can just do directly different predictions without any label also. This is what we call it as a zero shot, right? So it can learn and predict with no label. So how can we use this? So I tried this first for to segment different salt bodies in the subsurface from seismic. We built this, what call it a salt GPT. So in this case, now you just bring the seismic image here, and then you can use different prompts, and then you get the segmentation directly only on the salt bodies, right? So this is again one of the main benefits of using foundation models. Although one note is to train this foundation model, it is very computationally expensive, and you need a lot of resources and data set. But once you have this model, you can use it in for many different aspects, and also tasks that you want to do later on. Again, this is mostly on seismic. Now we can do also seismic facies analysis directly. You see here, for example, I can just use point prompt. I can just highlight it, the area that I want to analyze. It will highlight me what is it exactly, what kind of seismic facies. And even I can just say, okay, I want to focus on the deepest facies or the oldest facies, then it will just give me or highlight me this result here, right? But if I want to use everything prompt, they call it, so I will get everything highlighted as in terms of seismic facies directly from your seismic data set. And then lastly, we come up with this because most of these models are working with 2D because most images are in 2-dimensional. Now we try to expand it for 3D because the nature of seismic data is 3D, right? So in this case, for example, here we train it with 18,000 3D seismic cubes. Again, it's a huge data set. But once we're able to do this, then you see we can do fault interpretation, channel interpretation, so on and so forth, different downstream tasks, different interpretation tasks directly without any labeling, and then just bring the data, and then you get the interpreted results directly from this. Now, lastly, let's talk about in the large language model or GPT models. I mean, again, I'm sure most of you are aware how things are working. You train a language model with a lot of text input, right? Again, it's mostly large unlabeled corpus of text data set, and then later on you try to fine tune it, right? And this is very important in our case. We need to fine tune it because, again, to train a large language model from scratch, it is very expensive to do. Luckily, many of these models are available now, so we just need to fine tune it to our specific case, and I will show you later on how we can use it for our specific, in their data set. But beyond that, really, what this serves us, or what this gives us, is when you have this Chat GPT, for example, it becomes very accessible. Like this technology, AI, is become very accessible for us. For non-experts. So like if I remember during my time back in 2019, 2020, to learn everything, the coding and everything from scratch is quite, is quite a nightmare. But now you just can write a simple code, a simple prompt here to write a code to do, let's say image classification. Then ChatGPT will give you all the, the code directly. Even if you are really lazy, you just want to get this image, for example, take it from Google, and then write a Python code from the image, and then the ChatGPT will understand, okay, this is a vision transformer, for example, and write you the whole code. The code may not be working directly, but most of the time it works fine, and maybe you just need to tweak it, slightly here and there. So this, for those of you that want to start with this should really help you, speed up your learning process. And looking into the other side becomes also make geoscience accessible for everyone, right? For example, here I have this thin section. Then after you fine tune it with some prompt engineering, then you can get the results of your thin section analysis. For example, this kind of description of floatstone, skeletal fragments, this can only be done by experts, right? So now with all this technology, you can just use it with small tweaks. You can get the information that you need. So it becomes, again, make the domain very accessible to everyone. So one thing that I want to show you is, I mentioned before, how can we leverage this technology? This is what we call as hidden oil, where you try to turn this legacy data into insights. So as you know, we have thousands, if not hundreds of thousands, well reports. Mostly they are very old and very low quality, and nobody will look at it again. But now with this technology, we can not only analyze the well report and get some information from it, and now we employ what they call it as agentic system, different agents here to get different insights, right? For example, what we are doing here is, this is an example of old well report, right? Which is, back in 70s or 80s. Then from here, we built a system, large language model and agent system, to tell us about the CCS potential, or the carbon capture potential, from this well and also this field, right? So in this situation, you can see like the executive summary is pretty comprehensive, telling us whether this has a good potential for CCS. And again, remember, this is all well report only design or focus on oil and gas, right? But now with all the climate change, sustainability, and everything, we want to sometimes reuse this information to help us to know about the carbon capture and storage potential in that area, or in depleted reservoirs. And that even with this, we can come up with different criteria to rank the potential there, right? For example, we're dealing with two different formations, Utsira and Ecofist, and you can see how the agent actually try to extract and gain information from this and give us all this information directly. So again, this will become very useful for us to turn all this legacy data into information and also new insights for us. So I think when it comes to this, the potential is still really huge, and it's pretty much still untapped. It's still very few works dealing with this. So I think in the future, this is something that we can really focus on. So some key take-home messages. Again, the future of AI, again, this is mostly my personal take, is very bright and exciting, mostly because everything now is much more accessible, and we have more and more data sets open. So it helps us really to not only use it, but also build a proper model that can work with our data set. Then the next point is, when you're using all this technology, it really becomes like all the analytical or the interpretation that we are doing become much more efficient. That's the whole idea. Again, it's never the idea to replace the human or to replace the experts, but at least we want to make it much more efficient and optimize it. And so it will enhance the precision and also reducing the cost to in terms of exploration. Then another thing that hopefully, as I've shown you different examples, you can see that the model is very highly adaptable. It can be used in a wide range of exploration problem, and it can really help us to mitigate some of our key challenges. And sorry, lastly, as always, I think when it comes to application of AI in our field, it is a paramount that for us to integrate between subject matter expertise and AI to be able to really push the application and to really get the most of the benefit from this technology, and making the energy exploration much more sustainable and trustworthy. So that's all from my side. Hopefully it's clear, and thank you very much for all your attention, and I'm happy to answer any questions. Thank you.
Thank you very much, Dr. Ardi, for the amazing presentation. It was quite exciting. And going back to the slide where the slides were made with AI, I personally could not differentiate if they were
exactly. Yeah.
So that was amazing work. We'll be taking questions from the audience if any have. You can either raise your hand or write your question in the chat, and we'll read it out loud. Mr. Abdul Malik, please go ahead.
In the name of Allah, thank you so much. I'm Abdul Malik, petroleum engineering student at the Soran University. I just want to thank for everything, for new knowledge. Actually, is new for us as a student. Is a new knowledge because AI, especially for us, for future engineer in the oil field. I just want to thank for everything. I'm familiar with the new topics and useful knowledge. Thank you so much. Thanks for everything. Thank you.
Thank you, Abdul Malik. That's really kind. Thank you. But yeah, I mean, I do think, again, I mean, as a student, as a young generation, I mean, it's pretty much nothing to lose, right? I mean, if you go and try learn about this technology, I mean, honestly, I can only see the benefit. I don't think there is any drawback learning about this technology. But then, once you know about this, I think you can decide whether this is useful or not. But I think this is something worth investing your time and efforts.
Any other questions?
No.
All right. Seeing that there are none, again, Dr. Ardi, thank you very much for joining our monthly speaker. It was an amazing presentation, and thank you for the audience for joining. I hope everyone has a good evening. Thank you.
Thank you. Take care. Thank you, Ali. Bye-bye.